Assalamu alaikum students, again Faizullah Umar with class 10th chemistry. Today we are going to study Rutherford and Bohr's atomic model. In our previous lesson we have studied about history of atom, Dalton's model and his theory, and J.J. Thomson's atomic model. If you remember that, J.J. Thomson told us atom is a kind of plum pudding in which positively charged fluid is filled and electrons are scattered around, suspended inside the fluid. But this led to another question. He answered to a question, and we know that sometimes this happens in our life. When you answer to a question, your answer leads to another question. Same thing happened when Thomson discovered electron, and he said that positively charged fluid is filled inside the atom. Now other scientists started thinking that what is the positively charged fluid? They were trying to find out. So which eventually led to the discovery of nucleus and proton. Who discovered nucleus and proton? Yes, you guys know that he was none other than Ernest Rutherford. Yes, exactly. In 1909, Ernest Rutherford performed a gold foil experiment. He bombarded alpha particle to a very thin gold foil. He found that some of the alpha particle from its beams are deflecting into various directions, around 1 in 800. And somewhere else I have studied that 1 in 8,000, 1 out of 8,000 alpha particles were deflected. What happened? Let me show you in the diagram. This is a gold foil experiment. Okay students, over here there's a radioactive source. It is placed in a lead block. Why it is placed in a lead block? Because lead is a very dense metal. It can absorb radioactivity and some rays. That's why they place it in the lead block. So over here a beam of alpha particle is coming out, and it is striking it is hitting the very thin gold foil. Rutherford observed that a lot of alpha particles are passing through. Okay, that's all right, but very less amount of it is deflecting into various directions. Over here you can see there's a fluorescent screen, and you can see some of the alpha particles are deflecting into various directions. They're scattering. Why? There came a question in the mind of Rutherford. He was expecting something like this. He was thinking that if an atom is a kind of tiny ball and there is a solid fluid filled inside, a positive fluid filled inside, and electrons are suspended, the alpha particles must pass through it. But that didn't happen. So what happened? Something like this. The alpha particles, most of them were passing through, but some of them were deflecting into various directions. He thought that there must be something dense, positively charged mass in the center of the atom. He called it nucleus. He said that there's a nucleus which is a positive charge, and the alpha particles, when it strike or when it collided with the positively charged dense nucleus, it deflected. It changed its direction. Yes, this was his prediction. So he proposed an atomic model. He said that an atom is composed of empty space, mostly with electrons orbiting around the fixed positively charged nucleus in the center. Let me show you the atomic model of Rutherford. This is the atomic model of Rutherford. Nucleus is inside in the center, and electrons are scattered around the nucleus, and they're revolving around the nucleus. They're revolving. This could be also one of the model of the Rutherford. You can see nucleus is in the center and electrons are revolving around the nucleus. Okay, they're revolving. What happens if they're revolving? There are some drawbacks in the Rutherford's theory. Obviously, he discovered nucleus, he discovered a proton, we respect him. But there were some drawbacks. What were the drawbacks? What were the faults? What were the mistakes? He wasn't able to mention about the arrangements of electrons in the orbit. the first one, and the next one is he was unable to explain the stability of atom, and he was also unable to explain the atomic spectrum. And to solve this problem, there was another scientist in 1913 who came and he said that, what did he say? Let's check. Yes, he was Niels Bohr. In 1913, he modified Rutherford's atomic model, and he said that electrons are revolving around the nucleus in the fixed orbits and with the fixed energies. He says that electron energy in this model is quantized, which means that electrons have specific energy in every level, in every orbit. And he says that there is empty space between two energy levels, and electron is not present in that space. Let's have a look at Niels Bohr atomic model. This is Niels Bohr atomic model. Electrons, nucleus, and this is what? Energy level. What did we call this? Orbits in Rutherford's atomic model, but Niels Bohr called it energy level because these orbits had fixed energies. For example, if one electron is revolving in this orbit, in the first orbit, it has a specific energy. If we give energy to this electron from any outer source, like we can, with the help of light, like heat or electricity, it can jump to the higher energy level. It will jump to the energy level which suits its energy. For example, it gains energy, it can jump to third, fourth, or maybe upward in any energy level. But again, it will lose its energy and again fall back to its previous state. Because electron must have a specific energy to stay and to orbit in the first shell. And the other one, same. As much as we go to the higher level, energy level increases and the energy of electron will also increase. And the sayings of Niels Bohr was also true with the atomic spectrum. We will study atomic spectrum and electromagnetic spectrum as well. Just an introduction in our next lesson, maybe next lesson, and in that lesson I will also again review Niels Bohr atomic model before the modern atomic theory. Yes. Okay, students, for today is enough. Take care of yourselves, and if you have any question and any suggestions, you can write in the comment section below.